Alright everyone, so in this example, a car travels around a flat curve of a radius of 450 meters with a coefficient of static friction of 0.85. We want to draw a free body diagram of the car and figure out what the maximum speed would be that the car could drive without slipping. So that maximum speed is going to come about when the car is driving and the centripetal force essentially is greater than the force of static friction. Once that becomes greater than the force of static friction, the car is going to slide, and you feel this when you drive your car around a sharp curve. It's the same type of problem. This is exactly what we want to think about. All right, so here we have a car driving around a curve, so this is kind of like a top view. And we know that the radius is equal to 450 meters. And the coefficient of static friction, 0.85. So if you think about this with the car on the ground and the y dimension, the normal force and the force of gravity are going to cancel each other out. They're going to be equal to each other. This is because it is a level, flat curve. If this were not the case, you would have to account for gravity in this as well. In the x dimension, if we think about the car resting on the ground, the centripetal force has to be equal to the force of static friction in order for it to stay solid and moving. So as soon as the velocity is great enough, the centripetal force will be greater than the force of static friction, and that will cause the car to slip. And so if we want to know the maximum speed, we just have to figure out what's the speed when they're equal. Now remember, the force of static friction is related to the normal force. And here the mass of the car doesn't matter. And we can determine the maximum velocity by just solving for v. And you find the maximum velocity is 61.22 meters per second. So think about what this would be if the car were not flat. If the car is on an incline, then the force of static friction and the force of gravity play a role, as well as the normal force. And so you'd have to account for both of them.